what if we could understand when, where, and why blue whales were singing? We built a machine learning model to classify the 2 units which make up the repertoire of northeastern Pacific blue whale songs. Each unit is distinct. There is the A call and the B call, and together they are repeated in stereotyped sequences and are thought to serve as reproductive displays. Our workflow starts with hand-labeled audio data, which then gets converted into audio images called spectrograms. We used an open-source Python package called Open Soundscapes to build a convolutional neural network that can classify our spectrograms as either of the 2 categories, and subsequently generates an automated record of blue whale presence in our audio data. Our model performed well on the test data set. In fact, it found many calls that had not been originally labeled because they were too faint. There are a few important caveats about the model that are worth mentioning. It will only work for the 2 categories it was trained to identify, and it may have a difficult time generalizing to a new type of data. For instance, a different type of recording device or a new location with unique acoustic properties. Our model and workflow document an end-to-end example of using convolutional neural networks and open-source code repositories to classify whale sounds in underwater audio recordings. This work is not only beneficial as a tool for classifying blue whale songs, but also for describing how an integrated machine learning workflow can be leveraged by other bioacousticians with their own important ecological questions. As ecologists, we need reproducible methodologies, well-documented examples, and interpretable machine learning workflows if we are to leverage state-of-the-art AI technology for the purpose of conservation and management.